All right, hi Monitorama. Quick intro, as Jason said, I'm Brandon at Solars, and I like GIFs, so I thought I would share a couple that I like with you. Recently I've been into what are called doodle GIFs, where you kind of take something and add a little like eyeballs and other fun things. Another good one. All right. Oh, okay. So some of you may know I work at Travis CI. I work on a team that we call Build Infrastructure Engineering. At a high level, this represents kind of job execution, build logs, and infrastructure operations as sort of our areas of responsibility. And to set a little context for what I want to share today, I'm specifically going to be talking about our build logs and what that means. So a little bit of a history on Travis's build logs is that when Travis was becoming a thing and starting to become a distributed system, we designed the build log system to deal with small chunks of ANSI text that we call log parts. And so essentially while your build is running, every few bytes or every half second, we're taking the text that's coming back from the SSH connections running your job, putting that in a RabbitMQ as what we call a log part, and then that log part is then being processed into Postgres and eventually stored into S3. And so this design has scaled fairly well since it was implemented like 4 years ago, in part because it allows us to transport things simply, right? It's just a few bytes of text, and then we can sort of outsource a lot of the scalability around storage and serving it to S3. But because some of those original design decisions, what that means is that the build logs, they're not indexed, it's not built in a way that they're searchable, and ultimately what that then means is they aren't potentially available for us to use for different kinds of telemetry. So then that kind of leads into, right, there's a challenge, right? We've built the CI system and it's become, a fairly large CI system. We're executing millions of jobs a week. And by design, a CI system is one that generates a constant stream of errors. But the majority of these errors aren't relevant to us that are building and running Travis, right? They're relevant to a developer or a team or maybe a larger open source project, but some of them can be. A good example of this is shortly after I started, I don't know, I've been at Travis a couple of months, so it was like, around Q3 2015. I was working, and I live in LA, I'm on the West Coast. I'm one of the couple West Coast people in Travis. Most are Eastern or time zone or in Europe, and one of our support folks was like, hey, we started getting some tickets that Git clones are failing in our Mac environment. And our Mac environment is kind of interesting because it's more of this like enterprise stack. It's privately hosted. We're running vSphere and vCenter with Apple hardware and SAN storage and dedicated Cisco firewalls and pfSense and VMs for natting for things. And so there's, it's this more kind of almost like private cloud, if you will, type of environment. And so, I being the only person in build infrastructure around at the time, because it was maybe 3 or 4 p.m., I start looking and, I'm looking at some of the build logs and I'm saying, okay, Git clones are failing. And so then I'm like, well, maybe it's some kind of a network issue. So I, check on the Ciscos, check on bandwidth, check on pfSense, CPU, kind of all these things. And no, everything on the network level seems fine. And then, so I'm going back, I'm staring at these build logs, which if any of you have looked at a build log, it's a lot of text. And then finally I noticed it's, could not clone, could not resolve github.com. And then I'm like, oh, okay, so all right, well, is GitHub having DNS trouble? No, everything's fine. GitHub says they're good, our Slack integration with status page hasn't alerted us to anything. So I'm like, okay, I'm not as familiar with this environment. So I'm like, well, what DNS servers are we using, right? We should probably be using, local resolvers forwarding 8.8.8 or whatever. And we were using the upstream DNS servers provided by the hosting provider that specifically does this Mac stuff for us. So ultimately, it was a DNS issue. Their primary DNS server was having some kind of an issue. And so that was ultimately what manifested itself originally as users saying, hey, our jobs are failing because we can't clone from GitHub. And it took a while to suss it out, right? And similar to what Bridget alluded to yesterday, right, is like once you've been burned by the stove, you always check that. And so for me, having run a lot of network edge NAT infrastructure, that was the first place I looked. So this is one good manifestation of like, say if we were able to take the fire hose of this build log data, right? Like extracting something like errors from the git command out of it right? We could add some kind of a search or something, right, that could look for this in the future and specifically be like, oh, git clone failed, and it was a resolution issue that would, let us hone in on that more. Some of the other challenges, right, third-party service outages, pretty much any time PyPy, Ruby Gems, or Launchpad, which is notably not highly available, those PPAs go down, we get a lot of, hey, my builds are broken, what's going on, right? And similarly, there generally is data that points towards that in the build log, but it's typically masked, it's like apt-get update fails with a 404 or some kind of other error, or Ruby Gems is failing on bundler update, but those kind of failures aren't as apparent to users who maybe haven't, dealt with a Ruby Gem outage before or something. They just see like the build failed, it wasn't in my tests, what's going on? And sometimes it can just be stuff changed somewhere, right? Left pad, when that was, briefly removed was a good example because that was a lot of like Twitter and support tickets. People are like, hey, what's going on? So there are these potentially useful sources of data in these build logs. So, right, okay, we have build logs, we're generating them, it's text, right? Surely it's easy, right? Make that indexable, make it alertable, make these errors discoverable. But, okay, well, what does that mean? What does it mean to take that log data? What does it mean to index it, make it searchable? And so this is a conversation that in part we've been having as long as I've been at Travis in terms of, do we want to take this thing that we intentionally built to be simple and scalable and mostly we see as noise, if you will, for us and, do something with it. So, right, that discussion, well, you start with, okay, well, which tool, right? Just stand up some Elk, just stand up some Graylog 2, something like that. Well, then that leads you to running Elasticsearch, which, most ops people are like, please no. And Elasticsearch is a great tool in some ways, but it has had a rough history operationally in some ways. And so then it's like, well, do we build? Do we buy? Right? What kind of ownership are we taking on just by virtue of the fact that most of the common tools that are available if we want to build something do rely on Elasticsearch, and so you can end up with these big Elasticsearch clusters, and so it's even a question of, well, what if we bought Elasticsearch instance, Compose.io or Amazon or someone else who sort of they at least you can pay them for the operational overhead. One of the ways that we've talked about approaching this is our .org builds. So those of you who aren't familiar with Travis, there's travisci.com, which works for private GitHub repositories, and then travisci.org, which works for public GitHub repositories. And they're separate. They're separate infrastructure, separate. You tie them into your GitHub account separately, different subscriptions and things. And so Travis has provided this open source service for any public repository on GitHub for a long time, and so a lot of people use it. So we do have this large amount of data that is being generated that is also public by default. So it makes it a little easier to potentially start undertaking an experiment to say, okay, well, what if we stood up one of these things and then we could try with 24 hours, right? Potentially grow that to 3 days, to 7 days, but even just like the process of sitting down and figuring out how to, build an initial MVP of something and then start populating that requires a certain amount of time and investment and, trying to figure out, well, what's the scope and what would that mean? And then how do we measure what it would cost to make it bigger? That gets even more complicated if we look at the travisci.com build logs, right? Because these are private by default. There's potential privacy concerns around that. Customers who are using us for their private builds, just by sort of default are inherently, more sensitive in a way, understandably, about like, okay, well, what are my build logs? And so, not every user, public or private, may necessarily be conscious of the current state of how the build logs are stored and whether they're indexable or not. But, if we were to make a change like that, we would probably want to talk about it and blog about it and, and say, hey, like we are making this more easily like accessible and searchable that, at the very least would potentially raise questions. And, no matter how many FAQs you write, how much documentation, there's still a certain amount of people that they just email you or they reach out, or, like the way it was written wasn't quite answering the way that they had the question. And so even just, implementing this could potentially mean an increase in support load for at least a brief period of time as we have to answer new questions. And right then, ultimately, there becomes a question for us of, okay, if we make this searchable, does that actually constitute an increased threat to our users, right? Even if it's something that we build internally, we decide to operate all the pieces of it ourselves, we run our own Elasticsearch clusters, everything is locked down in the same way that the rest of our infrastructure is. We use the same access controls that we use for other internal resources, right? Does it potentially increase the threat scope for users if someone were to get into that and then potentially search it, right? Versus like if someone were to somehow get into those S3 buckets where things are stored, they would have to start extracting it, and they would have to build something themselves to index it and make it searchable and try to look for something to harvest. So it becomes a matter of, okay, it might be more convenient for us, but then also what potential new threat does it present, right? And so these are some of the the questions that I think aren't as obvious on the surface when you think, okay, well, there's a string of text and I want to turn it into something that's indexed. We've been finding ourselves playing out. And so again, I come back to this, like, it's easy, right? Because I feel like it's kind of easy to say that, and as technologists. And so then, right, ultimately, we potentially say we do build this and we say, okay, we can afford to do it for 24 or 48 hours, maybe up to 7 days, just to kind of keep a cap on costs, and also figuring out utility. I believe it was the talk from Slack on Monday. They said, we do 2 weeks, and we found, or 18 days maybe, but something like that, and we found that to be generally enough, which I thought was cool to hear, and it's nice to validate, because I feel like even in previous jobs I've had where, it's like, we want to log stash all the things and elk all the things. I've seen some of those efforts almost like get stalled before they even get it, because it's like, well, how can we afford to do everything and store it forever, and how would we architect that, and how many disks, and you get caught up in the planning phase, and it's like, because for some reason that is sometimes, I think, inherently as engineers, that's where we want to go. We want to build the thing. It's the penultimate, right? You get the same thing with metrics. It's like, we'll graph all the things, right? If it moves, graph it, right? So those are some things, and they are pithy, and there is some inherent truth to them. But then, there's still sometimes reality sets in, and that can be where things get a little more frustrating. It's like, okay, well, can we actually afford to do that, or what does it mean to scale that? And then, an interesting aspect for us around, potentially enabling this is, okay, we'll say we build it internally. Well, then, theoretically, users might want that. So what would it mean to make this a feature? What would that mean in terms of added scope for security, additional authorization? If we, use like something that's more off the shelf, would we have to build something to sit between it and our website and our API to deal with the way we authenticate our customers as users versus how we potentially authenticate ourselves as a single group? And that adds additional operations costs, and then support costs and infrastructure. And in our case, it also then leans into enterprise, right? We have this Travis Enterprise product. It's installed on site. What would it mean to say to customers, hey, this new feature then requires that you potentially need to stand up your own Elasticsearch and your own, Graylog 2 or whatever we chose, and then, what additional documentation, support resources would we have to give to a customer or to customers to enable them to use it? And so, where that leaves us then is so where we are right now. In a lot of ways, we are still in the discussion phase. These discussions have been happening over time. Often, new people join, and it comes up. And in a lot of ways, it hasn't been the biggest priority, right? Because there are potentially like these sources of telemetry, but when you look at it, we think, okay, relative to the fire hose of data, it might be 5%, 10% useful, and other features or infrastructure stabilization, things like that, have become a priority. But in the meantime, right, we have tried to say, okay, like, we have incidents where part of the retrospective was, hey, it'd be really cool if we just could search on that in the same way that we are able to search on the logs that our application generates, right? So we have various backend services and our API and all these things, and those logs we do send into Papertrail, and we do, have things to turn those into metrics and searches and alerts, but right, that's a much more sort of targeted, controlled way in which we are deciding what to log and what to turn into metrics, as opposed to, right, the seemingly potentially similar problem of build logs, but which is actually much larger because users can theoretically do anything up to the the limits that we put on log lines and log size, and so we have much less ability to control and influence that, and potentially have to filter that. And so what we have done though is in particular we've tried to add a lot of metrics. We look at things like we have this backend service called the worker, which is responsible for, it takes your job, it says give me a VM, give me a container, whatever, it runs the job. Each time that job finishes, it updates the state. So we generate a metric and we look at, over time, okay, well, what percentage of jobs are erroring, what percentage of jobs are failing, what percentage of jobs were canceled, how many finished successfully. And we can look at those as trends and, set thresholds and say if there's a big spike in error jobs, well, that could be a sign that maybe, there's a routing issue between, our stuff in Amazon and Fastly, or RubyGems is having an issue, or PyPy, or NPM, or whatever. And so, we've tried to sort of figure out, okay, how can we at least, give us metrics and alerts and things that sort of try to give us a little bit more of an aggregate picture, and then, try to look for sort of spikes, anomalies, things like that. And we definitely think we've had some good success in that, and just sort of trying to add metrics around a little bit more of a view of the system, and we continue to look for those and try to figure out what else we can do. So with that, I want to say thanks and kind of open it up for questions. Yes?
What do you do if Elasticsearch goes down during the build process?
So the question was, what do you do if Elasticsearch goes down in the build process? So at this point, we haven't built anything that uses Elasticsearch.
Well, I guess what would be your plan in that kind of architecture? Do you just accept that the build is okay or fail or whatever and then move on? Dead letter queue?
Well, so if we were to build something where our build logs were also being ingested to something that maybe was stored in Elasticsearch, it wouldn't be part of the critical path. The way that our build logs are done right now is that each of these log parts, as I mentioned, which is a chunk of ANSI text, is put into RabbitMQ, and then there's a pipeline of other backend Ruby services that take that out of RabbitMQ, put it into Postgres. Eventually, we aggregate and archive it off to S3, and so somewhere in that phase, probably like during aggregation, we would emit that to the, into like a forwarder or something that would then send it into a system to make it indexable. Yeah. Yes?
How do you make money?
How do we make money? Okay, so builds for private repositories on GitHub are paid, and we charge based on the number of concurrent builds. So like 1, 3, 5, 10, 15, etc. And then on the open source, but the public side, any public repository, there is a limit of 5 concurrent builds for free as part of that.
And is it not too expensive to run?
Is it expensive? Yes, it is. We spend a lot on infrastructure, which is interesting too in and of itself because relative to what we spend on infrastructure, we have a fairly small set of steady state services, and the majority of those we actually run on top of Heroku, which is a whole interesting subtopic on how Heroku has let us get by with maybe less traditional ops or DevOps-y type, people focusing on that. But when you look at some of our EC2 and GCE bills, You think, wow, that's a lot of servers, and it is a lot, but most of them, live for 10, 15, 20 minutes. So there's a high turnover rate. Yes?
You mentioned some issues with various package repositories like IPI. Have you looked at doing like internal caching mirrors to avoid these kinds of issues?
Yeah, so the question was, since we do often see issues where a package mirror for some language has instability, and have we looked at looking at caches or mirrors? It is something that, yeah, we've definitely talked about it. It's something that I've even talked about and we look at. But again, similar to the build logs, it becomes a matter of what's the overhead, what's the operational cost and additional, right? VMs that live with potentially large disks, maybe a lot of RAM if we want to try to, serve most things out of something like Varnish. And then what is the operational overhead, right? Especially if we say try to run our own mirrors of things, because for some of these tools, there are some pretty good tools to let you mirror it. What additional maintenance overhead does each mirror bring, right? Potentially there's scripts that run, on the hour or the day, and well, what if that script breaks? Where does it send an error? What do we do about that? And with a lot of these things, it does come down to like, what is the operational overhead relative to the impact? And the reality is the bigger we grow, the more these things like the value versus opportunity cost of spending time with support and with investigating when there are issues, it starts to get potentially more and more valuable to actually take on the ownership of building and running these kind of things ourselves. And the space is also maturing. Artifactory is an interesting one. I know some of you may follow John Vincent Lucis on Twitter, and he's been in love with it for a long time, and it's definitely got interested by proxy because they seem pretty quick on doing that. It's like, okay, well, there's a Docker registry, and now we can mirror that, and like they're constantly adding, and so something like that might also be an option of like, okay, what if we could just buy something and run it? And in general, Travis actually takes an approach of we buy a lot, kind of starting with Heroku, and then on top of that, looking at things that have a good Heroku add-on experience, whether it be for Postgres or Redis or RabbitMQ, or we use Librato for metrics and Papertrail for our logging, and we do use some Pingdom, so we're a pretty big SolarWinds customer now, which is interesting because a few years ago I ran like Orion and IP Monitor, very different type of SolarWinds product, but yeah, I suppose that answers your question and more. Anyone else? Okay, cool. Well, thank you very much.